Okay, here's this video solution for problem 4.16. In this problem, we're given a few things. We know that we have a notch cut in metal that's 90 degrees. All right, so the angle that this makes is 90 degrees. Okay, we also know that there's a cylinder. All right, so this is a cross section of the cylinder. It has a diameter of 2 centimeters. Okay, so that would make this have a radius of 1 centimeter. All right, I'm going to go ahead and draw in a radius touching the metal point, okay, because we know that that touches at a 90-degree angle. Okay, so that radius would be 1 centimeter since the diameter is 2 centimeters. Okay. All right, so here's the center. We know it's a symmetric notch. Okay, this is our base plane. Okay, so we also know that the part is 1.3 centimeters above the base plane. And so what we're trying to answer is the question of how deep is the notch. Okay. Right, so we can call the notch, say for example, X. Okay, so there's the setup of the problem. So we can write down what we're given. We know we have a 90-degree notch. Okay, we know that we're 1.3 centimeters above the base plane. And we know that the cylinder has a radius of 1 centimeter. Okay? All right, so what we want to find is the depth of the notch. In this case, we labeled that X. Okay, so let's pursue a solution. Okay, so part of engineering is about drawing the right pictures and doing the right analysis. Okay, so if this is a 90-degree notch, okay, and this is symmetric, and we know it's symmetric because this is a cylinder, it's perfectly round. Okay, so this radius would be the same as this radius. Okay. The overall notch angle is 90 degrees. So what is let me blow this up a little bit. If this were the angle theta, what would that be? Okay. So I think we can tell that theta is 45 degrees. Okay. And then because this sits perpendicular to the surface, we can draw a line perpendicular to the surface. This makes a 90-degree angle. Okay. And so from there, we can solve for the overall length. This makes a triangle, where this is the hypotenuse. These are the two sides. Okay. We know this side, the opposite side, is 1 centimeter. Okay. So I can find the length L because I know that I have the relationship that sine theta is the opposite length, which would be 1 centimeter in this case, divided by L. Okay. So that being the case, I can then solve for L. Making sure my calculator is in the right mode. I get 1.414 centimeters for L. Okay. All right. But L, I drew this where it looks like it lines up with X, but it's not necessarily. I didn't draw this to scale. All right, so we have to think about that. All right, here's the length L. All right, let me change the color here. We got this length L. Right, and then we add on 1.3 to get all the way to the base. Okay, so looking at this relationship, we have X plus 1.3 is equal to the length L. All right, and we already know what L is, so we can then solve for X, and we have oh, I'm sorry, that's not L. This is L. This is, how much is this? This is 1 centimeter, so L plus 1. Okay, so X would be L plus 1 minus 1.3. And so we get to two significant digits, we would get 1.1 centimeters. Okay, so X is 1.1, and we've solved problem 4.16.